So in this problem we're asked to determine whether the set 2, 4, 6, 8, where we're viewing these not just as integers, but as integers in z mod 10z, right, the integers mod 10, along with the binary operation a star b just be given by multiplying a times b, actually gives you a group. And we know that to show you have a group, well, one, you have to have a binary operation. So it really must be the case that a star b gives you something else in G. It needs to be an associative operation. It needs to have an identity element, something which doesn't change any other element under that binary operation, and you need to have inverses. All right, so let's take a look. Well, first, if we use the normal multiplication mod 10, then when we multiply 2, 4, 6, 8, well, we know they're even, so they're going to give you more even numbers. The only thing we're a little bit worried about is that the product of two of them could be 0. But this can't happen because 5 doesn't divide into any of these, right? In z mod 10z, the only way you're going to get 0 is if something is divisible by 10, which of course means it's divisible by 5. None of those are divisible by 5. Okay, so we're really going to have a binary operation. Okay, next we need to check associativity. This is no big deal. This is just regular multiplication. We know multiplication is associative. Okay, so check. We got binary operation, we have associativity. What happens with the identity element? Identity means we should be able to multiply it by any other element in the set and it won't change that other element. Okay? Well, in particular, that means we should be able to find some identity element that when we multiply it by 2, gives you 2 back. Well, let's see. What if we did 2 times 2? 2 times 2 is, well, that's 4. That's not equal to 2. What about 4 times 2? Well, that's going to be 8, which is again not equal to 2. How about 6 times 2? Well, that's going to be 12, but then you have to reduce modulo 10, so it gives you 2. Ah, okay. So 6 might be the one. Well, let's check 8, just to make sure that that's not another example. Well, 8 times 2 is 16. Modulo 10 is 6. That's definitely not equal to 2. Okay, so 6, that's our candidate. Okay, but it has to be an identity for everything. So let's check 6 times 4. Well, 6 times 4 is 24. Modulo 10 is 4. Hey, that worked. How about 6 times 6? Well, that's 36, which modulo 10 is 6. And 6 times 8? Well, that's 48. Modulo 10 is 8. Ah. So, we've got an identity element. Okay, last we need to check that you have inverses. That means you can multiply any number in the set by some other number and get back the identity element. Now, in principle, we should be checking both directions, right? We have to put it on either side. But this is a commutative operation because we're using just the regular multiplication of integers. So we don't have to worry about the left or right in this case. Okay. So, for instance, we need to be able to multiply 2 by something and get the identity element, which is 6. Well, let's see. 2 times 8 is 16. Modulo 10 is 6. So that means that 2 and 8 are going to be inverses to each other. Okay, so we've handled 2 and 8. Now we just need 4 and 6. Well, 6 is easy. We already know 6 is the identity element. Right? It's its own inverse. 6 times 6 is already 6, so we're good there. So the only thing we have to find is, well, what's going to be the identity, or the inverse element for 4? Well, there's only one element left. It could be its inverse, right? Because 2 goes with 8, and 6 goes with itself, so 4 better go with itself. Well, let's check. 4 times 4 is 16. Modulo 10 is 6. That's the identity element. And so 4 is its own inverse. And so every element also has an inverse. And so G, in fact, is a group.